Now the next topic we are going to discuss, that is multiplication of complex number. That is, let z1 is equal to a plus iota b and z2 is equal to c plus iota d be two complex numbers where a, b, c, d are real numbers. Now we have to find the product of these two numbers, that is, we have to find z1 into z2. That is, write in the bracket a plus iota b into c plus iota d. So by using distributive law, we can say that a into c plus iota d plus iota b into c plus iota d. That is by distributive law. Again we use distributive law, that is a into c plus a into iota d plus iota b into c plus iota b into iota d. Here again we are using distributive law in both these two steps. So we can write it a into c plus iota a into d plus iota b into c plus iota into iota is iota square into b into d. And as we know that iota square is equal to minus 1. Therefore, a into c plus taking iota common from these two terms, we get in the bracket ad plus bc, and by changing iota square into minus 1, we get minus 1 into bd. So here we get ac plus iota ad plus bc minus 1 into plus is minus bd. So by adding or collecting real part, that is ac minus bd in one bracket and plus iota ad plus bc in the second bracket, we get the required product of complex number z1 into z2. So on the basis of this, we are going to find the product of two given complex numbers in the example. As example is that find the product of 2 plus under root 3 iota and minus 3 plus under root 3 iota. Now the solution is z1 into z2. Here z1 is 2 plus under root 3 iota, say, and z2 is minus 3 plus under root 3 iota. Now we will using the distributive law, 2 into minus 3 plus under root 3 iota plus under root 3 iota into minus 3 plus under root 3 iota. So it becomes 2 into minus 3, that is minus 6, plus 2 under root 3 iota, plus into minus is minus 3 under root 3 iota, plus under root 3 iota whole square. So here we get minus 6 plus iota is common and we get 2 under root 3 minus 3 under root 3. Plus under root 3 square is 3 and iota is iota square. And we know that the value of iota square is minus 1. And here we get 2 root 3 minus 3 root 3 is minus under root 3 because the term of minus is bigger than the term of positive number. So we get minus under root 3. And iota square is minus 1, so we get here minus 3. Then minus 6 and minus 3, that is a real part, that is minus 9, plus into minus is minus, under root 3 iota. So this is a required product of two complex numbers. Now here we will discuss how can solve the quotient of two complex number form. So the topic is quotient of two complex numbers. Let Z1 and Z2 belong to complex number such that Z2 complex number is not equal to 0. Then quotient of Z1 over Z2 can be written as Z1 into 1 over Z2 and 1 over Z2 can be written as a Z2 inverse. This is the one way to express Z2 into Z2 inverse, and then by taking the product of Z2 inverse with Z1 we can get the value of Z1 over Z2. And another method to solve this is we will discuss in the example. Before solving that example, we have to know the meaning of conjugate. Conjugate of a complex number. That is, if we have z is equal to a plus iota b, then changing iota to minus iota in z, we will get conjugate of z and denoted by z bar. So z bar is a minus iota b. If we say we have z1 is equal to a minus iota b, then z1 bar will be a plus iota b by changing iota to minus iota. And if we have z1 as a real complex number, that is 3 plus iota 0, then z1 bar will be 3. There will be no change. So this is all about the conjugate of complex number, because we are going to use the conjugate of complex number to solve the quotient of complex number. One method is there. We have to find the product of Z2 inverse and Z1. Then we will find the quotient of two complex numbers. But there is another way to solve the quotient of two complex number, and we will discuss in the example, that is as follows. Example is that solve 6 plus 3 iota over 10 plus 8 iota. So it can be done as follows. Solution is that we have 6 plus 3 iota over 10 plus 8 iota. That gives 6 plus 3 iota. That is another method. 10 plus 8 iota. We have to multiply and divide by the conjugate of Z2, that is 10 minus 8 iota, by changing iota to minus iota. So we have to divide and multiply the given quotient complex number by this quotient complex number, that is the conjugate form of Z2. So multiply these two, that is 6 plus 3 iota into 10 minus 8 iota, and in the denominator we have a plus b, a minus b. It becomes a square minus b square. So here we get 6 into 10, that is 60, 6 into minus 8, that is 64 iota, plus 3 into 10, that is 30 iota, minus 24 iota square. That is 6 into 8 is 48 iota, not 64. That is a 48 iota. Sorry. And 10 square is 100 minus 8 square is 64. Iota square is iota. Into iota is iota square. So here 60 minus 48 plus 30 iota is minus 18 iota. And iota square becomes minus 1. And again in the denominator 100 plus 64 iota square becomes minus 1, then minus 1 into minus 1 is plus 1. So here we get 60 into plus 24, that is 84, minus 18 iota over 164. So here we get 84 over 164 minus 18 over 164 iota. So here we get, by dividing these terms by 4, that is here we get 21 and 41, and here dividing by 2, that is 9 and 82 iota. So this is the quotient form of two complex numbers that can be solvable by this method by introducing conjugate of denominator or by finding the inverse of Z2 and then finding the product of Z1 and Z2 inverse, then we will get the same answer. You can do this by another method and check it out.